Anybody else have theirs to turn in? Okay, do you have yours to turn in? Thank you. Alright, do I not have anyone's understanding check? No. Okay, really quickly, because I need y'all to remember, because some of us are stressing and like, here's the thing. I need to stop talking and listen first. Please remember, is this necessarily going to be your final grade on this understanding check?
No.
I'm going to put feedback on here. We're going to go over things. And if you improve your understanding by the test, you'll be okay. Because some of us are sitting here beating our heads over stuff that we don't know off the top of our heads. So are you going to magically figure it out in the next 20 minutes? No. So let's learn some from this. I'll give feedback. I'll give it back. Probably not tomorrow, probably on Monday.
Yes, sir.
But let's look at a couple of these problems right away, because I think this will be informative. First off, I want us to look at this number 11 down here. Does it look familiar at all?
No.
It was on the thing.
Oh, that was just on your understanding check.
Oh, yeah.
Okay. Nope, it's on the front.
No.
Number 11 on the front was on your understanding check. Okay? Quick couple of things I want to point out. Because I am noticing this already, that most of us are forgetting a key detail. Everything, every trig ratio is in reference to an what? Angle. Known as the reference angle. When I look at number 11 here, what is the angle? 12. So I should never write sine of x or cosine of x or tangent of x. I should be using the sine of 12 or the cosine of 12. Everything needs to be in reference to this angle here. Which trig ratio would I be using in this triangle? This 18 is my side adjacent. The x is my hypotenuse. So Jalen, if I have the side adjacent and the hypotenuse, which trig ratio am I going to use?
What do I call it? I got
Cosine.
Say it again, Gabe.
Cosine.
Cosine.
Yeah.
We got to know that right off the top of our head. If you're forgetting it or you're struggling to remember it, don't forget the acronym to help us remember what each of the ratios are. So SOHCAHTOA. We've got adjacent, hypotenuse, I'm dealing with cosine. Specifically, it's the cosine of 12 degrees is equal to the side adjacent to 12 degrees divided by the hypotenuse. And this is something else that a lot of us are forgetting. On numbers 1 through 3, all I asked you for was the trig ratio.
Oh.
That's all I asked for on numbers 1 through 3. Cosine of 12 degrees would equal what? 18 divided by x. If I'm only asking for the trig ratio, I stop there. In numbers 1 through 3, where was a variable? I guess technically there's a sine of angle A, but specifically in numbers 1 through 3, all I asked for was the ratio. Did you need to go beyond this in numbers 1 through 3? No. Numbers 5 through 7, I asked you to solve for the variable. Now, I'm going over a problem with you that is on your homework that you might want to make sure you have correct.
We did
Can we
it
go over
together
10?
yesterday.
We did this one together already? Okay, so then make sure we understand this, because I saw us getting lost here. I saw some people trying to multiply by 18, and not just one or two, multiple of us. What should we be multiplying by here? The x. Right? X times, and I'm coming up here for space, but x times the cosine of 12 degrees is equal to 18. Remember, I want my variable on its own, so what do I still need to do? Remember, I want this x on its own, so I got to get rid of cosine of 12 degrees.
Okay.
Anything divided by itself is 1. So there's what x would equal.
X equals.
Yeah, it's like 18.40 sounds right.
Can we go over 10 and 13?
No, we can go over 13. 13 look familiar?
No. Yeah, we need to go over 12.
We're not going over 12. If you can do 13, you can do 12.
What the heck?
What do you mean, what the heck? Look at 13.
He said that.
Look at the picture drawn there.
I see a flag.
Anyone see a reference angle I could use?
I see a tank.
50.
10.
13, y'all.
Oh.
A reference angle.
50.
50 degrees. You have got to identify your reference angle first. 50 degrees right here. That's a reference angle. Now, I will point this out because I heard one student say this. I don't know how to solve it when I only have one angle measure. Do you need more than one angle measure?
Tangent.
Okay, well, we'll get to that in a second, but I need you all to pay attention and remember, trig only works with what kind of triangles?
Right.
Right triangles. And if this angle is 50, do you know what this angle is?
40.
40. And what do you know about every triangle that has the angles 40 degrees, 50 degrees, and 90 degrees?
That's
Equal
right.
180.
Huh?
Can you repeat what you just said?
What do we know about every triangle that has 40 degrees, 50 degrees, and 90 degrees?
180.
180.
We're missing an important detail. Every triangle that has 40 degrees, the ratios are the what? Same. Every triangle that has a 40, 50, 90 degree angle measure, those triangles have the same ratio because they are what kind of triangles? Similar. Everything is built out of this idea of similar triangles. So I can use just that one angle. I don't need the other angle. I know I'm going to have the same ratio throughout. How would what trig equation should I use?
Tangent.
Tangent? Why do you say tangent?
Because it's a side opposite and a side adjacent.
So notice you need to give me that evidence, right? Side opposite and side adjacent. Why is that adjacent? Why is this one not?
That's the hypotenuse.
So if you're going to talk about the adjacent, you also probably need to identify hypotenuse to maximize how much I can tell you understand it. Okay, so then I might say the tangent of 50 degrees is equal to the side opposite 50 divided by the side adjacent to 50 degrees, thank you. So the tangent of 50 degrees is equal to x, what's that? Divided by 20. Do not forget that trig is the tangent, the sine, the cosine of an angle measure. Should always be the tangent of an angle measure. Okay, so now what do I need to do to solve for x? Multiply by 20, right?
Yes.
20 divided by 20 is
You said
1.
1.
Okay, and so x is equal to?
1. I didn't mean to say that.
Y'all, we all got calculators. You're never going to figure that out just staring at it. I don't know that answer without a calculator. What is x equal to here?
1.175.
You got what? Did you multiply by 20?
50.8.
50.8?
23.
Hold on, hold on.
23.8.
23.8.
You're late.
Wait.
Why are y'all confused?
Why did you use multiply?
That ain't calculator, right?
What's confusing?
No, I'm looking at that's the right one.
What did you just multiply by?
Well, you see how it's x divided by 20? I want to solve for x. So I need to get rid of the division by 20. What undoes division? So I need to multiply by
20.
whatever I do to one side of the equation, I do to the other. Why do I have to do it to the other? To make sure the equations are equivalent, right? Well, she's going to do it tomorrow because we had the same check today. But I know. Yeah, don't forget, if I talked to you yesterday about taking your test, because you haven't done it yet, You gotta do it tomorrow. We did the understanding check today, so if you have to make up your transformations test, you better study. Or come in during a class that you're not doing anything. Alright, really quickly, hey, eyes on this, because this is an important detail to remember. When I say that the tangent of 50 degrees is equal to x divided by 20, instead of multiplying by 20 right away, you don't have to do this every time, but I want everyone to take a calculator and do the tangent of 50 degrees very quickly. It's okay. 1 point what? 1.1975? Equal to x divided by 1 Okay. I need y'all to look at this, because this is going to help you understand an important detail that I think some of us are also missing. Do not forget,
Multiply by 2.
well, we can, but so you're just focusing on a process of calculating, but I need you to remember, what does this 1.9175 mean actually? Well, remember, this number came from the tangent of 50, right? And what is the tangent of, or what is tangent? It's a ratio of what to what? Side opposite to side adjacent? Well, this could be understood as being divided by what number? What number? Say it again. 1. Remember, everything is always understood to be divided by 1. Because that means the same thing. So I want you to notice what we are actually saying here is the tangent of 50 degrees, the side opposite, for every 1.19175 for the side opposite, the adjacent is how long? 1. What we're saying is that the side opposite to the side adjacent has this ratio. Well, I know that my actual triangle is x to 20, and so when I solve this equation, I'm finding what value of x gets this ratio. Right? I'm finding what value of x gets that ratio. Notice, if I take 23.8 and I divide it by 20, pick up a calculator, it was 23.8 divided by 20. So it's a little bit rounded, but is it giving me this ratio?
Yeah.
That's the whole point, is that I know I need this ratio, so when I solve this equation, I'm finding the value for x that gives me the correct ratio. That's what's happening mathematically. Alright? One last thing, and then we're going to look at the last topic we are studying this year. Uh-oh, we're almost there. Number 13, this seemed to give us some trouble, even though yesterday everyone was very adamant, man, Mr. Kinney, this is the easiest stuff, right? Let's look at this number 13.
No.
Don't go completely blank. First off, I will point out, this is the one place where you could use the Pythagorean theorem. Stop and listen. Why could we use Pythagorean theorem here?
We
got two sides. However, do I care what this side is?
No.
No. Right, so if I were to ask you to find the third missing side, you could use Pythagorean theorem. We all good with that idea?
Yes.
Okay? But what I asked you for is to find
The angle.
measure of angle R. Does anybody see a way that I could get that angle R? An equation that I might be able to use?
I got 34.
So this 14, is that side opposite?
I got 0.6.
Yes? Okay, and then what is my hypotenuse? 25? Brooke, how do we know that this is the hypotenuse, that 25 right there?
It's opposite of the 90 degrees and it's the longest.
Now, one thing I want to clarify is this. Do we actually know, like looking at these side lengths, do we actually know that this is the longest side?
No.
Why not?
Because you just
Say it again.
Just say a calculator.
Yo, stop and listen. You're missing an important detail that London noticed. What?
Because we don't have the other side.
We don't have the third side, right? So do we have conclusive evidence that that's the longest side?
No.
No. However, and this is why we want to focus on what a hypotenuse actually is, it is opposite the 90-degree angle. Now I will say, because I know it's the hypotenuse, I do know it's the longest side. But I can't say, oh, this is the hypotenuse because it's the longest side. I don't have that side. But it's across from that 90-degree angle. That's what we want to focus on. Now, what equation can I use if I have the side opposite and the hypotenuse? Sine. The sine of what?
R.
Boy, you ready to say that?
Bro, what is wrong with you?
Use arc.
Hold on. I don't have the ratio yet. And remember, I want to show as much evidence that I understand this is possible. Don't touch him, Josh.
Yeah, Josh.
Hey,
Watch your language.
there's no need. It
Brandon.
doesn't matter. That term shouldn't be a derogatory comment in the first place.
Huh?
So, what is the sine of R?
Arc sine.
14
14.
divided by 25. Now that I have my ratio, I can use what operation? Arc sine. The inverse of that sine is
Arc sine.
arc sine. Now I need you to focus on this because I saw a lot of students doing silly things that didn't make sense. You need to identify what operation I need to, or what you need to undo. The reason why we know it's arc sine is because I'm solving for what?
R.
R.
Yeah, R by.
What do I need to get rid of?
Sine.
Sine, right? I need to identify what operation I need to get rid of. I have the sine of R, so I need to take the arc sine of both sides. And what is the arc sine? Is what? Now let's stop there.
I got 34. I got 34.1.
What would that round to?
34.1.
Okay.
I just told you that.
All right.
I don't care, man.
So, I hope that this gives us some more of the background to help us finish our homework. We've given you a couple more answers. Bashar, if you picked up a pencil instead of pulling on Austin's sweater, you might have more answers and know a little bit more.
Man, Mr. King.
My fault. Yeah, I'm a fruit cake.
I agree.
Hey, really quickly, hey, listen, because I hear a lot of students stressing about why didn't this come to my head. Remember, the understanding check is just a check on understanding. It is not the end of your learning, because learning never stops. We want to keep going and learn from it before the test. All right, so actually I'll let y'all copy down some more of the information while I pass out today's task. Rose, why are you talking across my room? You can be working on your homework right now.
You shut
Yes, but or not.
Oh, phone out.
Any ideas? Put it in the calculator. Take the arc sine of 14 divided by 25. Thank you. Okay, so Alana's asking a good question, and this is something we want to pay attention to. Listen, okay? Why are y'all talking? I'm trying to teach. So, Alana asked a good question. She said, how do we know when we're supposed to use the sign of R or the sign of 12 degrees? Is that what you were basically saying? So look, if I have an angle measure, I'm going to take the sine of that angle measure or the tangent of that angle measure. Remember, sine, cosine, and tangent are always in respect to a what? A reference angle, right? So if my angle has an angle measure, well then I'm going to do, that's opposite, that's adjacent, I'm going to do the tangent of 23 degrees. Is equal to 30 divided by x. So you have to identify your reference angle first. And if the reference angle has an angle measure, then tangent of 23. If you look here though, if I'm looking at this angle J right here, does this angle J have an angle measure? No. That's my reference angle though. So this is opposite, this is hypotenuse, so the sine of angle J, I don't have the angle measure, is equal to 10 divided by 12. Pick the reference angle, and if you know the angle measure, put the angle measure in. If you don't, you put the variable in. Okay? Now, there are certain ratios that are so applicable or so used throughout the rest of mathematics that you have to know them. And so I plan to get to circles, but we won't have time. We will end on this topic right here because this is a topic that you have to know. They are the special right triangles. Well, we're talking about it today. I might tell you all to not have it completely filled out because we need to know this. So right here, first off, does anyone know what the angle measures are for the special right triangles?
Man, it's bad.
No. The individual angle measures for the special right triangles. Give me one of the special right triangles. 30, 60, 90. How'd you get that?
It's on the board.
It's on the board as a part of our what?
Say that.
Objectives. One of the special right triangles is known as a 30, 60, 90. Anyone know another special right triangle? Tyson?
45 and 90.
45, 45, and 90, right? These two triangles will show up. Austin, pay attention. These two triangles will show up throughout the rest of the math that you do. Especially if you make it to pre-calculus, but definitely in Algebra 2 with stats, and if you make it to pre-cal and pre-cal. So, we want to be able to use the extended ratios of the special right triangles to solve a special right triangle. What do I mean by solve a triangle? Identify all side lengths and all angle measures. Right? So when we have special right triangles, we're going to use these ratios to help us solve the special right triangle. And then we're going to use this to determine exact trig ratio. So here's the deal. We're discovering the 45, 45, 90 special right triangle. In this discovery activity, we'll be looking at one special type of right triangles. Through this process, you'll be able to discover the rules for a 45, 45, 90. If you follow these directions, because I've done this with many students, you will discover these ratios and they will make sense. Start with a square that measures 1 unit on each side and draw the diagonal. Right?
Yes, sir.
So, 45, 45, 90. Start with it. So we're starting with a square that measures 1 unit on each side, and we already have the diagonal drawn in this square. You want to finish going all the way to the other corner? There you go. So fill in the blanks below to identify the measures of each angle. Talk about it within your small groups. I'm going to give you 60 seconds to figure out what those angle measures might be. Think about the fact that that diagonal is a diagonal that is cutting the triangle or the square in half. Think about what those angle measures might be.
Hey, you're working on the wrong sheet. Which one?
You say yes or that makes sense? I guess.
I'm telling you, I'm just gonna just look.
Oh,
Okay.
hey, don't do that.
Alright, Bashar, what did y'all say? What?
There were like 3 other people, bro.
Cause y'all were playing.
Bashar acts like I only call on him. And it's funny, because then Brandon, whenever I call on him, he acts like I only call on him. And Josh does the same thing.
Why you calling me?
What are you calling me, bro?
I don't understand nothing. I answer the question sometimes.
Okay, Bashar, I'm calling on you this time. What did y'all say the angle measures are?
We didn't do it.
You didn't do it. See, this is why this is a problem. If you focus and were trying your best, I probably wouldn't call on that group as much.
Stop calling us.
Then do your work! Rose, what you think?
45, 90.
Oh, wow. Where did y'all come up with that?
It's beside it. It's beside it.
Okay. Listen, hold on. Mari, what are you thinking? You just said stuff. I couldn't hear you. What were you thinking? Kelsey, what are you thinking?
The bottom left, degrees, and the other two 45.
Okay, why do you... Anyone have an idea why that might be 45?
Because if one of them 90, the other side, the other two got equal to 92. So 90 divided by 245.
Okay, so are we just always going to divide 90 by 2?
No.
No, but it's
I mean, so like, here's the thing. Let's say I had a triangle like this.
no.
Would that be 45, 45, 90?
No.
Well,
6 30.
not necessarily.
Not necessarily.
I will agree this is 45, 45, 90, but why?
I know the bottom left is 90. And
Oh,
I got 45.
Okay, so one, I want to point out, let's use our logic here. It's a 45, 45, 90 degree triangle. That's all we care about, right?
Yes.
So that would make sense. 1, 2, hey, what do you think this entire angle measure is? Then, I didn't hear you. I gave y'all a chance to talk, and y'all said, oh, I have no idea, okay? Uh-huh. So, focus. That would be a 90 degree angle, wouldn't it? Hey, y'all, 90?
Yeah.
And what are we not doing to that 90 degree angle?
Taking it off.
We're splitting in half.
Oh my god.
That diagonal is splitting that angle in half. So what are these two angle measures? So it is a 45, 45, 90. So when we have a square, there are too many people talking while I'm talking. When we have a square and that diagonal cuts it in half, what kind of triangle are we left with?
Right triangle.
No.
45, 45, 90.
Thank you. Yes, it's a right triangle. But say it again, Zaria.
45, 45, 90.
A 45, 45, 90, right? The diagonal's cutting this in half. Now, label the two sides of the square by its length of 1 unit. Use Pythagorean theorem to find the length of the diagonal of the square. So, what do we know the side lengths are? 1. So what are we trying to find? It says nothing about angle measures.
The side lengths?
Nope. Okay. Ari, how are we going to find the length of that diagonal?
She don't know because she just got back 45, 90.
You don't have to know. It's not something I've taught you. Look at the directions.
Oh, what?
You're going to use that Pythagorean theorem, right?
Yeah.
Because what do I know these two sides are?
She was here.
1 and 1. So use that to help you figure out what the hypotenuse is, or which will be the diagonal of the square. Notice we want it in simplest radical form, okay? So work within your small groups, find what that radical is. It will be a radical. So it's be finding the length of that diagonal. We're trying to discover the ratio of 45, 45, 90. What do you mean? What do the directions say?
I got it.
Tell me what they say.
I got one going.
Yeah, you work quick. Never mind. Yeah, you read.
What do you not understand? It tells you exactly what to do. Use what? What is
Leave it on there, dude.
What are we doing now?
I wasn't.
We want it on ratings with what I agree.
At least I know about
Everything we're doing is in degrees.
I wasn't paying attention.
I gotta go check on other groups. Y'all need.
I'm saying that. I'm
Plus
used to
they
this one.
will.
I'm used to this one. So I just turn. I hear it.
How old?
Got you the voice, so I turn back down.
I didn't even scared.
No, I'm talking about. I'm used to this one.
No, because my other students aren't doing the tangent of 50, so that would only be in this class.
I'm good.
You walk straight in there.
I was in there.
Josh, no one else would have done any of this beforehand, so this is one of you four.
There's bad. A whole bunch of girls that came over the side.
Lady, what are you doing?
I don't know.
That's it.
Put that.
Thank you. Thank you. Thank you. Thank you. Alright, Jalen,
Yo,
did y'all figure out what the length of that diagonal is?
no.
Why
Try
not? How did you get it started at least?
it. Yeah.
Okay, what'd y'all start with?
I did 1 square plus 1 square. There you go.
Equal to C squared.
Remember, the whole thing is a squared plus b squared equals c squared. That's the big start. What am I going to do now?
Square.
You want to square them?
Yeah, what's 1 squared?
2.
Two.
I mean,
One.
Plus?
You one that was going to
2 squared.
Equal that little thing.
I need an equivalent equation, y'all. 1 plus 1 equals c squared. Now what?
Simplify, I guess.
2 is equal to c squared.
Then you do the little thing.
The square root. Square root.
I know how to do that.
Y'all, stop. Too many of y'all are not focused, and now you're struggling with what is 1 squared?
1,
1. So both of these are 1. What is 1 plus 1?
2.
That's it. Oh. Do I know what c is yet?
No.
So what do I need to do?
Take the square root of 2.
The square root is the inverse of a square, is it not? It is. So if I take the square root,
1.2.
the square and the square root and the square are going to cancel. Don't put the square root of 2 in the calculator.
I was just going to do that.
Express this measure in simplest radical form. So it'll just be the square root of 2. We are going to leave these angle measures, or these side lengths, in radical form. So the length of that diagonal is the square root of 2. It's nuts. But do I need to re-explain anything, or can we move on?
Move on.
Move on? Okay. What do you have a question about? Yo, I'm trying to teach. What do you have a question about? Okay. So right here, we've slightly changed it. How so?
What? Oh, they added.
Make it smaller.
It's sliced in that.
Yeah.
There are 2.
Each side is how long? Each side is how long?
2.
Y'all,
There's 4 squares.
2.
that's not what I asked. Each side is how long?
I'm making it 2.
2. And I know some of you were saying that correctly, but I didn't ask how many squares there were. I asked how long is each side. By the way, did anyone actually read the directions?
Yeah.
What did the directions say?
units on the
Oh, each side is 2 units long?
Ah.
Y'all, read your directions. This is why I'm frustrated, because we're just shouting things without thinking or reading. So what is this length up here? 2? So how am I going to find the length of that diagonal?
Multiply? No.
2 squared.
Same thing? 2 squared plus 2 squared equals c squared. What are we using?
Squares.
Bro,
Pythagorean.
Joshua, stop throwing things at me. I don't appreciate it.
We're using the Pythagorean theorem. Please remember, because some of y'all were trying to use Pythagorean theorem earlier,
I show you.
how many sides do you have to know to use Pythagorean theorem?
2.
You gotta have 2. Remember, if you have 2, you can solve for the third, but you have to have at least 2 sides. Okay, so now what?
Alright, 2 squared is 8. No, 4.
4.
4 plus 4 equals c squared.
8 equals c squared. And then square root c squared and 8.
So c squared is equal to, so what I need to do?
Square root.
Square root.
Ah.
Now, I need y'all to pay attention to this, because we have not dealt with radicals this year, and so I'm not going to expect you to simplify radical, but we need the simplified radical in order to understand the whole point of the 45, 45, 90. So I'm going to walk you through this so that you can get to the final answer. Why are you talking, Gabe and Kyson? I need y'all up here, though. If you have a question, ask the whole class, because then I can clarify and it might help the whole class. But I need y'all up here, if that's not what you're going to do. So, when I look at the square root of 8, are there any factors, remember a factor is something you are multiplying by, are there any factors of 8 that you could take a square root of?
Yes, 4.
4?
Yes, 4.
Can you take the square root of 2?
No.
Wait, is it
Say
4
it.
squared like 60?
Yes, but what squared is 4 is the real question.
2 squared is 4.
2 squared is 4. So so notice I didn't change anything, I just rewrote it. 8 is 4 times 2, isn't it? Okay? One of the properties of square roots is that when you have factors like this, you can split it up. So I can rewrite this as the square root of 4 times the square root of 2. This is a property that we don't have time to explain why it works, but I need you to hear me very clearly that when we have a square root and you have multiplication here, you can split it up into the square root of 4 times the square root of 2.
So we can't leave this.
Well, I'm going to walk you through anytime you need to simplify the radical, we're going to use this to learn something. Can I take the square root of 2?
No.
No.
No. No, yes, you can, yes.
I mean, you can, but what are you going to get in the calculator?
What?
You can get a decimal, and a really ugly decimal at that.
It's like 1.
So I'm not going to take the square root of 2, I'm going to leave it as the square root of 2. Can I take the square root of 4 easily?
Yes.
What is the square root of 4? 2. The square root of 4 is 2. Square root. Did you get 4 squared? Yeah. Square root of 4 is 2.
It's okay to make mistakes, Matthew.
Thank you. What? Hey, focus up here. So, we're about to go into the next one. But I want you to see, is there a pattern? And so, hold on, don't say anything out loud yet. What I want you to do is I want you to work within your group for 60 seconds. And I want you to look here. When it was sides 1 and 1, we got the square root of 2. When it was sides 2 and 2, we got 2 square root of 2. So within your groups, make a prediction about how long this diagonal will be. Talk within your small groups, noticing what's happening. Make a prediction about what that length of that diagonal will be. So talk within your small groups.
You on word.
No, we just did number 3. Number 4.
Oh, I thought you were trying to. Wait.
I'll screw them.
Okay, I heard some predictions. And I'm kind of intrigued to hear what everyone else is thinking. Zario, what was your prediction, or what did your group agree upon?
Oh,
Prediction doesn't have to be right, it's just a prediction, it's a guess.
We said it's gonna be 3 squared plus 3 squared equals C squared.
Okay, I mean, that may be true, but remember, I'm just asking you to make a prediction about what the length of the diagonal
Oh, it's
is.
gonna be, I said 3 times the square root of 2.
3 times the square root of 2?
yeah.
Give me a quick thumbs up if you were thinking the same thing, or thumbs down if you were disagreeing.
How you gonna disagree? You could have said that.
Not sure?
I
Thumbs up? Okay, I've got several of us who are agreeing with this idea. Okay, so please notice, this is the truest sense of math. We have gotten some evidence, we made a hypothesis, now we need to do what with that hypothesis?
Test it.
Test it, how are we going to do that?
By doing
You start us off. You're right. 3 squared plus,
3 squared equals C squared.
okay? So what is 3 squared?
3
Nine.
squared is 9.
Plus, equals,
A equals C squared and AC equals C squared.
and then I need to
The square root.
stop. So let's look right here really quickly. Square root of 18. Are there any factors of 18 that I can take a square root of? Matthew? 3. No, I can't take a square root.
We would appreciate it.
2.
Hold up. Stop shouting things.
9.
Stop. First off, sit down. First off, is 4 a factor of 18? No.
I said 9.
Okay, let's talk about 6. Put the square root of 6 into the calculator. Do we get an integer?
We
Or do we
get
get a decimal?
1.44. No. You get a decimal.
You get a decimal, so I don't want the square root of 6.
I say 9. I say 9.
Can you take the square root of 9?
Yes.
Remember, you want to think through what are the perfect squares. 1, 4, 9. What's next?
11.
1, 4, 9. What's the next one?
12. What?
1, 4. Sorry, 4, 9.
Oh, 16.
16.
Bro, nobody cares.
25. 36. These are the perfect squares, the things you can easily take the square root of. So I'm going to rewrite the square root of 18 as the square root of 9 times...
Wait, you said what?
9 times 2. And then the square root of 9 times the square root of 2. Can I take the square root of 2?
No.
No, I'm going to leave it like that. What is the square root of 3? Or square root of 9?
3. 3 times 2.
Was Zaria's hypothesis correct?
Yeah. Good.
So notice we had, and this is a good detail to notice, y'all listen, when the side length was 1, we had a 1 square root of 2. When the side length was 2, it was 2 square root of 2. When the side length is 3, 3 square root of 2. Is there a pattern there?
Yeah.
Oh yeah. Patterns like this is what math is built out of. It's confusing? Okay, let me see if I answer the question. What is confusing about this?
You have a trick thing?
They haven't cheered no matter.
Oh, she had a cheer. Did it?
I never said to measure this diagonal. In fact, you cannot measure that diagonal. That was actually a really important proof in Greece in a really, really long time ago. In like BC era. You can't actually measure that length. You can approximate it. But that's the thing. We do understand 3 squared plus 3 squared equals c squared, right? So that's 9 plus 9. which is 18.
Okay, so you going off like how we saying one square across and one square.
Right. We know that this length is 3, and we know that this length is 3, so I have to use the Pythagorean theorem to find the hypotenuse.
Oh, I've done that before.
What? Okay, first off, I want you to remember, you're not going to have to simplify a radical for me. I'm telling you, once we simplify, we get 3 squared to 2. Right? So there's a pattern there. So, here's the next part. We want to notice right here that when the length of each leg, remember this, when we say leg, what are we referring to?
The length.
The side that is not the legs are the side of a right triangle that are not the hypotenuse.
Move, bro.
The legs are the side that are not the hypotenuse. So each length of each leg, right? These are the sides, not hypotenuse. And remember, those are the sides of the square. Y'all, it ain't that funny. I'm trying to teach you math. Pay attention.
Yes, sir.
So when the length of the side of the square was 1, what was the length of the diagonal, the hypotenuse?
2 square. 2 was square root of 2.
Or 1 square root of 2.
Yeah.
Matthew, when the side length was 2, the legs were 2, what was the length of the diagonal?
Those.
No.
2.
What was that mean? What did I say? What did I say?
You said dose, 2.
No, it's actually 3.
No.
No.
You're trying to pull crap out of your butt. Listen, didn't we just look at the square when the side length was 2?
Yeah.
Look at your paper. When the side length was 2, it's on the front side, Matthew. When the side length was 2, what was the diagonal, the hypotenuse? No.
1.
Yeah.
2 times the square root of 2. 4.
Oh! Stupid. Yeah.
Wasn't that the hypotenuse?
Yeah.
Uh-huh.
Yeah.
Thank you. So Josh, when the side length of the square is 3, what's the hypotenuse going to be? We just did this one, Josh. You don't know? Rose. 3 times the square root of 2. Okay. I need y'all to notice this. There's a little diagram to help us right here. Notice when the side length is 1, that is 1 diagonal, or the square root of 2. When the side length is 2, see how we have 2 square roots of 2? It's 2 of those diagonals.
Yes.
So when the side length is 3,
Now it's 3.
now it's 3 square root of 2.
The more you know.
So now when we make a bigger square,
It's a
They cut it.
when the side length is 4, what's the diagonal going to be? 4 square root of 2.
Oh, okay.
Is it 4 times?
Remember, when they're written right next to each other, it's understood that it's multiplication. Okay? Now, this is something I need you to pay attention to, and this is important. Y'all, this is important to notice. There's obviously a very clear pattern, but it's not just the square. We're really not as focused on the square as we are on the what? Okay, the hypotenuse of a what? Triangle. Remember, we're using the square to get the 45, 90 degree triangle. So when the side lengths of the triangle are 4, what's the length of the hypotenuse?
4.
4 square root of 2.
I'm so smart.
Matthew,
No,
you're not being productive right now. And it's not about how smart you are, it's about how hard you're working. No, it's how hard you're working. When you work hard, you learn.
Yeah, that's what I said.
I know. I also want you to notice this. Hey, stop. When you have a 45, 90 degree triangle, the side lengths, the legs are what?
4. No.
The legs are equal.
It goes a little bit.
The lengths of the legs are the same. The side lengths are the same in a 45, 45, 90 degree triangle. Because guess what? The angles are the same. So if the legs are each 5, the diagonal is
2, 3,
5 times the square root of 2. Remember, if I add another square in here, so that there's a side length of 5, I have 5 square roots of 2 as those diagonals. So, Ren, what'd you say for the next one? 6.
6 square root of 2.
6 square root of 2. So if the side lengths are 7,
7 square root of 2.
what's the next one?
8 square root of 2.
You didn't have to do
And
that.
then 9.
I don't know, I think you might need to look at that last one again. Amari, what'd you say?
X times the square.
Say it again. It's an X, not a 9, so it needs to be...
X square root of 2. Yeah?
OMG.
How am I out?
Y'all are moving tomorrow.
Okay.
I was just.
Okay,
Hey, please don't.
stop. So I need you to notice this. Zaria and Anton, y'all are going to move soon too. I need you to focus.
This our first time.
First time.
This is our first time.
Compared to them.
So, what we're saying is, if I have a 45, 45, 90 degree triangle, whatever this side length is, what else is going to be that X?
Yeah.
What else is going to have the same side
The
length?
other leg is gonna.
The other leg is going to have the same side length. And then what would the hypotenuse be? Remember, it's X,
X.
X,
X squared. X square root of 2.
X times the square root of 2.
Wait, what? So,
Remember, if it was 6 square root of 2.
so
8 square root of 2.
So you're not going to multiply, so you did 1 times square root of 2, you're not going to do 2 times square root of 2?
Well, if it's a side length of 2,
So you're not going to do
it's
that?
2 times square root of 2.
So why are you not putting the times?
Matthew, if you write numbers right next to each other like this, it's understood to be multiplication. What is happening between my 2 and my X right now?
Multiplying.
Okay. Right?
Yes. Okay.
That multiplication symbol is understood.
Understood.
Now,
It's understood.
I want to point this out. You can use this. 1, you should draw this under number 6. 2, you can use this triangle to figure out the trig ratios of 45 degrees. If I were to ask you, what is the tangent of 45 degrees? Remember, this is true for every 45, 45, 90 degree triangle. Well, if I look at this 45, what's opposite that 45? It's X. What is adjacent to that 45? And what is X divided by X? So what is the tangent of 45 degrees always equal to? You can use this generalized 45, 45, 90 to figure out the lengths or the ratios for any of these. Now, under number 6, what you need to write is 45, 45, 90. Those are the angle measures. The corresponding side lengths would be, what is the generalized symbol that we would use? What is the generalized symbol that I'm going to use to represent any side length? X. So, 45 degrees would have a side length of X. And then the other 45 degrees would also be X. And then the 90 degrees would be X.
Squared?
Not to the square root of 2 times
Times square root.
square root of 2.
Good
That is
afternoon,
known as an
Hillcrest.
extended
All students
generalized
of English second
ratio.
semester, remember to review your
That is
assigned
the
summer
ratio
reading
of the
novels over
45,
the
45,
holiday.
90.
You will be tested
We
or
will
have an
use that
assignment
tomorrow
once
and we will look at the 30, 60,
Please refer to
90.
the Hillcrest High
And that
School
is going to be
website
our
to
last
review the
topic,
list
and
of
everything else is going to be studying and preparing for our test
The
on
English
Tuesday and
text
exam on
sections are due this
Thursday.
month, and they are major test grades. Math, reading, and science test grades are due in January with your have a good Thursday and be one class.
Wait, our damn Thursday? What's on Friday?
Exams next Friday.
Which exams, Luana? That's what I'm asking.
Hey, really quick now, we'll point out, y'all, stop the talking. Your homework, remember, the solving triangles using trig ratios practice. That's what we worked on a little bit in class today. Not the special right triangles, yes. The trig ratio circuit is what's due tomorrow, and the graphic organizer.
When my dad they don't want to do this squash.
Your dad not even dead. You just don't know what he did.
Oh, damn. That's not
That is what your homework is. Rose, can you scoot over a little bit so we can see? What? The white sheet we worked on at the beginning of class, that's this. Grab the understanding check. This is the blue trig ratio circuit. And your big idea is graphic organizer.
My granddad put me walked upstairs to go there. My fault.